This is a story about roads, how roads are made, and especially what's in and under the roads, rocks. Roads represent freedom and the ability to travel from place to place or between places. They are a way to obtain goods and services necessary for survival. Vital infrastructure usually exists along transportation corridors which supply us with our fresh water, electricity, natural gas, communication, and cable TV, as well as wastewater and storm drainage systems. Roads need good drainage. And in addition to good drainage, roads and the utilities located under or next to roads require rock. Processed rock, called aggregate, is necessary to support and protect the pipes that carry the utilities. A typical cross-section of a road shows what it looks like under the pavement and gives one an idea of the aggregate used in and under the road's surface. But did you ever wonder where this aggregate comes from and what is involved in providing these materials? The Rock Quarry provides these materials that we need and use for the roads and many other types of projects. Rock quarries come in different shapes and sizes. They have different types of rocks and geology. Our quarry started in 1910 and was called a shale pit. In 1989, we took over operation of this small rock quarry. We had a humble beginning. We had a very small staff, a low budget, and we were undercapitalized. That means there wasn't enough money for much of the special equipment we use today. We had a small trailer as an office and a temporary portable processing plant. The company grew slowly, and in 1997 BoDean acquired Blue Rock Quarry in Forestville. 4 years later, in 2001, BoDean Company took over operation of an existing asphalt plant in Santa Rosa. There are 4 major facets or components to operating our rock quarry. The first is mining, then processing, marketing, and reclamation. Mining involves a variety of tools and techniques to extract the rock from where it lies solidly attached to the earth. At times, miners could consider themselves as sculptors, artists whose job it is to carve and shape a mass to serve a larger purpose. We typically use a rock drill and explosives to liberate significant quantities of this material. We then gather the broken stone and bring it to the primary crusher hopper. This starts the processing. Once the broken stone is dumped or fed into the primary crusher hopper, large boulders, as well as the finer rock material, can be vibrated forward toward the primary crusher. Openings in the bottom pan of the vibrating feeder allow smaller sized material to drop out and avoid or bypass the crusher. Stones larger than 6 inches will not fit through the grizzly bars and will be fed into the primary crusher. The jaw crusher processes these rocks over 6 inches and can crush rocks up to 48 inches in diameter. If by chance the crusher cannot handle the rock because of its large size, a pedestal-mounted breaker is used to break the rock down. It's a very useful tool to facilitate production, as well as provide the safest workplace possible. Now that the stone has passed through the primary processing plant, it has been reduced to a size of 6 inches or smaller and can be conveyed and handled much more safely and efficiently. With the 6-inch minus rocks located over a surge tunnel, feeders suspended from the tunnel ceiling can feed or meter material onto a conveyor belt and deliver this material to a large vibrating screen with multiple screening decks to begin the primary screening process. This includes sorting out the largest stones by retaining them on the top deck and sending these stones, typically 2 to 6 inches, to the secondary crusher for reduction. The primary screens also have the option and flexibility of sending these large stones to a stockpile for applications requiring such a size. The middle and bottom decks of the primary screen may send the stone retained on them to a crusher as well, and in some cases a tertiary crusher. Once the stone is discharged from the crusher, it is often commingled onto a common conveyor belt and sent to a secondary screen, where the crushed stone can be sorted and dispatched to a stockpile or sent back to a crusher. They can also be sent to a tertiary screen where additional sorting or classification takes place. The stone can be screened and sent to stockpile, or recrushed and reclassified. Materials from all the screen towers sometimes need to be blended together to form various products, so flexibility to blend products together in certain proportions is important. One such product used frequently in road building construction is base rock, a blend of coarse and fine aggregate, usually 1 inch and smaller. There are rigid requirements and criteria in order for this product to meet specifications, and testing in a laboratory is important for quality assurance. Once the quarry has adequate quantities of processed materials in inventory, we are ready to market our products. Trucks are an efficient way to deliver material to its next point of use, although some quarries may have the ability to load rail cars, barges, or ships. The type of transportation is chosen on the basis of efficiency and cost effectiveness. Safety is a priority, as well as maximizing payload. Front-end, rubber-tired loaders can load whatever product is needed. The product is weighed, and a weigh ticket is produced. The material is then delivered to its desired location. Sometimes materials are transported to a facility for additional processing. One such facility would be a hot mix asphalt plant. Aggregate materials are stockpiled, blended, and fed into an aggregate dryer. This rock and sand is dried, classified, and mixed with hot asphalt to produce a mixture used to pave road surfaces. The mixture is a blend of approximately 95% rock and sand and 5% oil. Heated and blended at 3 to 325 degrees, it is laid and rolled while still hot to produce a smooth road surface. Within hours, this paved asphalt surface is cool enough to drive on and ready for traffic. Sometimes old roads made of concrete and asphalt can wear out and deteriorate. Broken asphalt and concrete can be crushed up and reused or recycled. This material is delivered to a recycling plant and after processing is reused as a road base. This makes it a reusable natural resource. Once an area has been mined, it can be prepared for a future use. Quarries are required to have a reclamation plan which directs how the quarry will be mined and reclaimed once quarrying is completed. Reclamation done concurrent with mining creates an optimum situation. Topsoil, or overburden removed from an area to be mined, can be used in an area previously mined. Drainage is the key to operating not only the mining areas of a quarry, but the reclaimed areas of the quarry as well. Slope stability and safety are essential priorities. Replanting the reclaimed areas can be accomplished in several ways. One innovative way of replanting is to relocate mature trees that are in the path of future mining sites. Much like moving topsoil and overburden onto a reclaimed area, moving trees rather than cutting them is an exciting way to utilize our natural resources and be good stewards of our planet.